So I watched the lecture on forecasting turbulence. So what did I learn that I didn't know? The first is chaos theory. So it's the idea that tiny differences in starting conditions can lead to vastly different outcomes. And this is directly relevant to turbulence, where fluid motion becomes highly sensitive and unpredictable. And another idea is that different patterns in airflow can be characterized and can be connected to fundamental descriptions or behaviors. Some examples introduced in the lecture are channel and duct flow and pipe flow. And the third idea is that Kolmogorov flow is a simple idealized fluid setup where smooth periodic forcing can become unstable and transition into chaotic motion, making it a clean model for studying how turbulence first emerges from orderly flow. So, what did I learn that I already knew? I knew that air could be modeled as a fluid, and I knew that turbulence in airflow over a wing can be modeled as Navier-Stokes equations in combination with Newton's second law for fluids. And I knew that turbulence is a switch of flow over time. So in the case of airplanes, it's a switch of airflow over the wing over time. So was there something in the lecture that really struck my curiosity? Some things were how can we use airflow classifications in Navier-Stokes to calculate airplane flight inputs to minimize turbulence? And is turbulence getting worse over time as the environment changes, and are planes getting stronger for our turbulence handling? And did it somewhat relate to my own area of study? So I'm a CS major, and there's currently some work being done on using machine learning and AI to predict turbulence in advance. So basically, these models take a bunch of data from flight sensors and prior data, and then try to use that to predict turbulence in the future. And then a lot of the computer models we use for turbulence simulation require, or they simulate very granular components. So they simulate tiny areas in the air, every shape and bend in the wing. And doing this requires a lot of compute, and a big field computer science is high performance computing, which basically is the work of computing or simulating things that are very computationally expensive. You see these things in high dimensional modeling. You also see these things in training very large and sophisticated AI models, which is why you see these GPU companies and semiconductor companies doing very well. And did I follow up on this topic outside of lecture? So I went on and did some research on current methods of turbulence detection and mitigation tools, and how dangerous turbulence really is to commercial airplanes like the Airbus A320 and Boeing 737. And the general consensus is that while turbulence can be scary for passengers, there is rarely a risk to the actual airplane itself, and you often feel your body might feel more turbulence than there actually is. And the greatest risk of turbulence is not an airplane crash, but it's more in a passenger not fastening their seatbelt and getting thrown around the cabin. So yeah, the general consensus is that turbulence is generally not a danger to the aircraft.